All right. Hello, Joel. I'm gonna make this video available to everybody as well, so not just Joel. So, but please take notes. Hello. Okay. All right. So we left off yesterday at midpoint formula number 12. So we will continue with número. What's that? Tres. Transformación en rotación en la transformation and rotation of a point. So transformation, I don't necessarily need to cover it too much, I don't think. Transforming a point, I mean, you're just gonna what? I guess I can, well, let's see, what are my options here? I can horizontal or vertical shift, which just means what? I go up or to the right, to the left, or down, right? Those are pretty straightforward. The only thing that might be a little bit difficult is reflecting. So reflecting about the different axes or the origin. So if I reflect about the x-axis, and I've got some point x, I've got some point A, B, right? If I reflect about the x-axis, here's my point AB here. What's my new point? First off, if I reflect about the x-axis, I'm shifting over like this, right? I'm reflecting over like that. What's my new point? A negative B. Does that make sense, everyone? A negative B. I just reflect across the x-axis. And the y value becomes negative, right? So AB turns to a negative B. Okay? What about if I reflect about the y-axis? My point AB, now reflecting this way, becomes what? Negative AB. That makes sense? So you can remember it like this if you want. If I'm doing it across the x-axis, the y becomes negative. If I'm doing it across the y-axis, the x becomes negative. So it's like opposites. All right? What about if I'm reflecting about the origin? My point AB becomes what? Reflect about the origin, it becomes negative A, negative B. Reflecting about the origin is the same as reflecting about the x-axis and then reflecting about the y-axis. So you can see I reflect about the x-axis, I end up here. Then I reflect about the y-axis, I end up here. So with the origin, they both end up negative. Now, if I started with a negative point, they would both end up what? Positive. So it's not necessarily that they end up negative, it just, they become the opposite sign. Everyone got this? Pretty good? Okay, so that's reflection. All right? Now, what about, everyone get this? Good? Rotation. Say I have some point, once again, AB. And I want to rotate 90 degrees about the origin. Well, if I have some point x, y, and I rotate 90 degrees, what does that point become? Negative y, x. So my point AB becomes negative b, a. And if I were to draw an angle between those two, it should be 90 degrees, right? Okay. Now what if I reflect another 90 degrees? What would this point become? It would be negative a, because it swaps it, right? Swaps it, becomes negative a, and then negative b. Cool.
That's just 2 up to 180.
If I'd said 180 degrees, right? But the way that I would do it is just do 90 degrees at a time. Because then you don't get too confused, right? You don't have to memorize all the different ways, right?
What's the trick that you showed us? Just you add a negative or something?
Just swap it and make the first one negative. Or just reverse the signs. Swap it, make it reverse the signs, okay? Swap and reverse. I don't know, something like that. Remember it, I don't know. Still working on these memory techniques. This Brault apparently has like a million.
Huh.
I keep stealing them from her. Can't help it. She's good. She's been teaching me like 20-something years. All right. So if I rotate another 90 degrees, I swap and reverse, right? So it becomes negative b becomes positive b, right? And then negative a swaps to make negative a, okay? Cool? Now, to test that I did it right, I should, if I rotate this another 90 degrees, I should end up where? The original point, right? So I swap it, make it negative, right? Swap it. Oh, negative a is positive a, and that b ends up there. So swap and negative. All right. Very good. Everybody understand? Yeah? Feel pretty comfortable now? We're like on a big old fluffy couch. How comfortable we are. Your grandma's house, and she's about to like bring out the cookies from the oven. You're like,
So what is
My
it?
grandma's never made cookies. The stereotype on grandma.
I don't know if my grandma's ever made me cookies either.
What's the one for 180 about the origin?
It's okay.
I'm just kidding.
It's okay. It's okay. Maybe we should all go home and make cookies for our grandmothers.
Wow. Just that up real quick.
That's deep. All right. Okay, so everyone gets this now. Good. What about if I want to rotate? I'm just going to erase all of this now. Yeah. Okay. What if I want to rotate about, maybe someone can predict what I'm going to say. Rotating about what? About a point. I didn't know that I allowed gremlins into my math class. Okay. All right. So I have my point AB, and I want to reflect it about some point 1, 1. Okay? What do I do? First step, I take my point and I do what? Subtract the point that I'm rotating around, right? So it would be A minus 1. Let me do a real point just because it'll be easier. rather than doing it like this. So let's say I have 2, 3, okay? I have 2, 3. First step, subtract the point I'm rotating around, right? So 2, 3 minus 1, 1 is
1, 2.
1, 2. Right? 1, 1. So for this example, I'm rotating around the point 1, 1. Cool? So first step is I subtract the point. Second step, so first step I subtract. Second step I what? Who remembers? I rotate it as if I'm rotating about the origin, right? So 1, 2 becomes what?
-2,
Negative 2, 1. Right? Flip the negative, right? Flip the negative. There you go, that's a way to remember it. Alright. Then what do? So I subtract, I rotate, then what? I add the point back. So now I have -2, 1. I add 1, 1. Which equals -2 plus 1 is -1, 1 plus 1 is 2. So I get -1, 2. That's my new point right there. And if you look, just even this rough sketch, hey, that looks like I rotated 90 degrees about that point. Is that right?
It's a rough sketch.
Closer. Oh, see, I told you, I completely forgot.
I forgot too, that's why I got here late.
Did Nicole remind you? Yeah. Yeah, so right next to the Bible. All right. Very good. You can use a calculator. Okay, so I add the point back. There you go. Done. Anyone questions on this? No. Everyone understand that pretty well? I won't. So what are my points? I subtract, rotate, and add. Done. You can think of it as SRA. I'm sure we can get in contact with it though. Alright, so SRA. All you have to do is SRA. Subtract, rotate, and add. That's all you have to think. Subtract, rotate, then add. SRA. See, you guys are going to remember now because it's so ridiculous. SRA. What?
Why?
Subtract, rotate, and add.
Is that it for number 13?
That was transforming and rotating the point. Yes, exactly.
Okay.
Okay? Got it?
Yeah.
All right. And I'll remind you that your Thanksgiving review packet is a good review packet in general. But beyond that, your tests are good.
Did you give us any formulas?
No. Do you remember the last time you were
No, yeah, the law science. This one.
I can remember these notes.
Take 5 minutes to review. You have your book? Okay.
Oh. Like,
Guy?
oh, you should.
Should just
in and say hi.
At the end, I will.
You remember what it's on?
Alright, this is on our review time already.
Finding the area of the
This is
good.
our time.
This is good.
triangle.
This is good.
And compare the
This is
area
good.
formula, law signs, law placeholders. What do you got? Give me 5 seconds. Okay.
14. Vertical angle.
Vertical angles.
Vertical
Thank you, ma'am.
Teacher now.
Would you like the marker?
No.
Right.
Hey,
Okay, I mean,
careful.
honestly, it was pretty cool.
You're in here?
Maybe that's what we'll do for the final exam, is have you guys teach me,
Nice.
right?
Thank you.
And then you can grade me too, I'll take a test.
You don't even, sorry, you know what?
You know, information
Right.
go.
You don't even have to look
Okay,
at the
so
test when you go to the-
honestly, with vertical angles, the next few points here, I'm just reminding you that you have to know this stuff, right? Vertical angles, right? What do I know about vertical angles here? It all kind of has to do with this little thing here, right? If I have lines P and Q, right?
Wow.
P is parallel to Q, very good. All right,
Bingo.
good.
I wasn't talking about you.
Yeah, you compare there and
They gotta have some good lunch today.
Oh.
Cheese,
I don't care. I literally went like that and that's it.
what's that?
Okay.
That was a really bad imitation.
Oh. It's probably good for you.
That was a good invitation.
Sure. Yeah?
Like your purple.
Yeah.
You like today again? You late again?
My shoes
You
are
sure?
dirty.
How sure are you?
All right, so P is parallel to Q, right? P is parallel to Q.
Yeah.
All right, let's call this angle 1, 2, 3, 4, 5, 6, 7, 8. Who do you appreciate? Crusaders. All right. All right. So who can tell me a set of vertical angles?
1 and 3.
1 and 3. Good job. Another one?
5 and 7.
5 and 7.
2
6 and 8. 2 and 4.
2 and 4. Good job. What do I know about vertical angles? They are congruent. Vertical angles are
Nice.
congruent. Good job. Okay, so vertical angles is done. All right. Corresponding angles. Yeah, just reminding you guys what they are. So I guess we could write down vertical if you want, but I think you guys know it, right?
Yeah.
What are corresponding angles?
1 and 5.
1 and 5.
4 and 8.
4 and 8.
7 and 2 and 6.
2 and 6. There you go. Good. What do I know about corresponding angles?
Congruent.
Congruent.
Tiene cariño.
Ready?
Yeah,
1 and 5, 4 and 8.
Okay.
1 and 5.
Ay. Come on, man.
All right.
Get bugged.
What about, now there aren't any of these here, but what about complementary angles? What do I know about complementary
They
angles?
form 90 degrees.
Complementary angles,
Add up to 90 degrees.
angle 1 plus angle 2 equals 90 degrees. Right? Complementary angles.
Yeah.
Okay? We're together? Yeah.
The corresponding.
Did we miss the corresponding? Okay, so corresponding angles are what? 1 and 5, 4 and 8,
Oh, here, I remember.
2 and 6, 3 and 7, and they are
Yeah.
corresponding angles are congruent.
Oh!
Hey,
Okay?
I know.
Complementary angles
Okay.
add up to
They're
90 degrees. Look, class, this is a set of complementary angles. If this is 90 degrees,
Hey, stop talking. No more talking.
if this is angle 1 and this is angle 2, then angle 1 plus angle 2 is 90 degrees, and they are
Complementary.
complementary. Not necessarily congruent. The only way they'd be congruent is if what? Angle 1 would have to be what? 45. They'd both be 45.
That's the complementary. We want to hear here.
Okay?
That's what
Next is supplementary.
180.
Supplementary.
Supplementary angles add to 180 degrees. Who can give me a set of supplementary angles? 6 and 5. 7 and 8.
Oh, relax.
6 and 7. 5 and 8. 1 and 4. 1 and 2. 4 and 3.
2 and
2 and 3.
I like it.
Lots of supplementary angles
Wait.
there.
What's the difference between like adjacent and supplementary?
Nothing.
Also,
In this case, nothing.
Nothing.
Adjacent angles, though, for instance, adjacent angles could be like this. I could have two adjacent angles, angle 1 and 2. Adjacent angles are just touching. They share one ray. Okay? By the way, class, this is called what? A line segment. This is called what?
Array.
A ray. And this is called what?
A line.
A line.
do we need to know that?
Sweet.
Yes, not for the test, but just in general, it's good. I'm not going to test you on that, no.
Alright, man.
But line segment array. It's good just to be able to speak about this kind of stuff. This is a ray here, right? This is a line. You know? Okay. If I've got a polygon, the sides are each what?
Say it again.
The side of a polygon, if I put it on a graph, right, would be a line segment, right? Good.
Okay.
Supplementary angles add to 180 degrees. Very good. All right. What about alternate and interior angles?
4 and 6.
4 and 6. Very good.
3 and 5.
3 and 5. Are there any more?
Nope.
No.
Negative.
What do I know about alternate interior angle?
Congruent.
Congruent. Right? Alternate interior angles, 4 and 6, 3 and 5. Very good.
Just a second. Get ready down. Just a second.
Would you prefer that I go back and write a list for all the vertical angles and the corresponding angles and things like that?
What do you mean by list?
No, because I realize I haven't been writing it down and maybe I'm going too fast. You guys feel pretty comfortable with what vertical angles are and corresponding? That's the only reason why I'm not just writing the whole list. Right?
Yeah, we
Okay.
get you back.
But alternate interior angles would be 4 and 6 and 3 and 5. Right? Alright, what about alternate exterior angles?
1 and 7, 2 and 8.
1, 7, 2, and 8. What do I know about those? They're congruent. Very good. So 1 and 7, 2 and 8 are alternate exterior. They're alternate exterior because they're both on the outside, but they're on alternating sides of this line, right? So 1 and 7 and 2 and 8. They're both external, but on alternating sides. What about same side interior
4 and
angles?
5, 3 and 6.
4 and 5, 3 and 6. Same side of the line. Same side interior. I'll write these ones down because this one is we're less familiar with. Same side interior is 4 and 5 and 3 and 6. Right? They're on the same side of the line, but they're both interior angles. What do I know about same side interior angles?
Congruent.
Supplementary. How I can figure that out is look, 4 is a corresponding angle with 8, right? So 4 is congruent to 8, right? So 4 is congruent to 8, 5 and 8 are what? Supplementary. So 4 is congruent to 8 and 5 and 8 are supplementary, then 5 and 4 are supplementary. You see how that was basically a proof?
Basically.
Right?
B.
Okay.
Happy time.
What about same side exterior angles?
1, 8, 2, 7.
2 and 7, 1 and 8. Once again, same side of the line, but exterior. 2 and 7, 1 and 8. What do I know about those? Supplementary as well. So both the same side, interior and exterior, are supplementary.
So same side interior and same side exterior angles are congruent, right?
Mm-hmm.
They are
No.
congruent. They're not congruent.
Same side interior and same side exterior make supplementary angles. I should say are supplementary angles. Okay, now, if we look at number 21, that says, proofs for a line intersecting a set of parallel lines. So if we look, here's a line intersecting a set of parallel lines. So I could ask you basically any proof on this. You know, I could say to you, prove to me using corresponding angles and alternating interior angles that angle 1 is congruent to angle 7. Okay? So let's go through that. An example. Okay? I'd say prove angle 1 is congruent to angle 7 using corresponding angles and alternating interior angles. And you can assume things like supplementary angles, you have that. Okay? But corresponding angles theorem and alternating interior angles theorem. All right? So I'd say statement, reason. Okay, statement 1 is, or well, yeah, my given would have to be what? P is parallel to line Q. Line P is, I have to give you that. Line P is parallel to line Q. Reason given. Now you kind of have a hint because I'm saying you got to use corresponding angles. And I'm not going to try and trick you and say using this and this and you don't actually have to use them. I'm going to tell you what you have to use, right? But I'm limiting you to that because look, honestly, angle 1 and angle 7, what are those? Alternate exterior. I already know they're congruent based on alternating exterior, but I'm saying you can't use that, right? So I'm saying prove to me that the alternate exterior angles theorem is true using corresponding angles and alternating interior angles, basically, right? So we already know they're congruent, but we're limited in a sense. So what should I use?
Angle 1 is congruent to angle 5.
Angle 1 is congruent to angle 5.
And then you can say that angle 5 and 7 are vertical. And if one's...
But I didn't say you could use vertical
Then you
angles.
do 5 and 3, and then 3 and 7.
Yeah, I could.
Again,
All right. So good. So let's start where you left off, because there are lots of ways we can get there. So it's up to you just to figure it out and make sure you make sense, right? So he said, what? 1 is congruent to angle 5, and how do I know that?
Corresponding.
Corresponding angles. Okay, Now I have angle 1 is congruent to angle 5. But I can't use vertical angles because I didn't say you could use that, right? Otherwise you'd be there already. All right, but what could you use?
5 and 3.
5 and 3. You got a hint, right? You already used corresponding angles, so you say, can I use alternating interior? Well, hey, 5 and 3 are alternating interior, right? So 3, angle 5 is congruent to angle 3 because of what? Alternating interior angles. Very good.
When is it that we have to do a measurement of whatever equals measurement of so
If you're ever using supplementary angles. If I were to say to you something like, oh, angle 1 and angle 2 are supplementary angles, then I'd have to say, well, measurement of angle 1 plus measurement of angle 2 equals 180 degrees. And then remember, you'd have to use like substitution or things like that, right? So generally speaking, it's better if you can get away with not having to use supplementary angles, right? Because if you have to use supplementary angles, then you're adding a couple steps, right? But you could do it, okay? And I'm going to do one after this that does, so you understand how to do it, okay? So angle 5 is congruent to angle 3, good. All right?
Angle 3 is congruent to angle 7.
So, well, actually, now we have to actually here. Because, look.
And like I remember like
Right, no, you're right. You're right. You're right. We actually skipped a step. We always have to do that. I apologize. The measurement of angle 1 equals the measurement of angle 5, right? That's what we got from congruent, right? And how do I know that? Thanks, Sarah. Definition of congruency. Right? So we kind of skipped that step. We should have done that. Immediately once we say two angles are congruent, we should say their measurements are equal. Right? That should be the first thing you think. They're congruent, measurements are equal. Alright, so then I have to do it for the next one too. Measurement of angle 5 equals measurement of angle 3. Why? Definition of congruence. Alright, now with these two, what can I say?
Angle 3 is congruent to angle 7.
Well, before I move another step further, because I have measurement angle 1 equals measurement angle 5, measurement angle 5 equals measurement angle 3. What can I say?
Measurement angle 1 equals measurement of angle 3.
Measurement of angle 1 equals measurement of angle 3, right? And now, just recognize that all this is just kind of note-taking and bookkeeping here, because it's obvious, right? If I say 1 is congruent to 5, oh, well, 1 is equal to 5, right? And if I say 5 is congruent to 3, well, then 5 is equal to 3, right? Well, if 1 is equal to 5 is equal to 3, then 1 is equal to 3, right? Cool? All right. Now, I know angle 1 is equal to angle 3. How? Who can tell me?
Substitution.
Substitution. Property of equality. Now what? Angle 3 is congruent to angle 7. How do I know that?
Corresponding.
Correspondence. And if I know angle 3 is congruent, what's the first thing I think? Measurement of angle 3 is equal to measurement of angle 7 because of the definition of congruence. And if I know measurement of angle 1 is equal to measurement of angle 3, and measurement of angle 3 is equal to measurement of angle 7, what do I know?
Measurement of angle 1 equals measurement of angle 7.
Measurement of angle 1 equals measurement of angle 7. Because of what?
Substitution.
Substitution. Property of equality. And then my last step is what?
Angle.
What did I want to prove?
Angle 1 is congruent to angle 7.
Right. Angle, your last line should always be the thing you're trying to prove. Angle 1's congruent to angle 7, how do I know this? Definition of congruence. Very good.
Wow.
This is kind of a long one. On the test, I might not give you one that's this long, but I might. Okay? So just be aware, though, at the same time, that it's like fairly straightforward. Okay? How do you guys feel about this? Pretty good? Yeah? Rose? Pretty good? Good. All right. So,
Good for the day, or?
yeah, right. We have 15 minutes left.
Well, I mean, did you put the marker down and like stretch?
No, that's not.
Can't take it back.
I'm just saying. It's 6 black.
What did you say?
He said it's the longest one. I'm sorry. I'll try and be more exciting. I'll start juggling her. Swallowing fire or
It's
something.
not bad. It's just like, I think like there's only 5 minutes left and there's actually like 15 or 20.
Well, it's because this class is 5 minutes extra, right? Isn't it?
Of course.
I know it's not. No, it's not. It's just 50 minutes. Oh, wait.
Wake up.
55 minutes.
Wait, I don't think you can.
Okay.
Then she'd be knocked out.
All right. Very good.
What do you say?
Do you guys want me to do another proof?
No.
No, oh my goodness.
Relax, right?
I've never seen a class so united.
The one who flipped.
All right, just to say though, if I said angle 1 and angle 4 are supplementary, let's say I wanted to use that,
Yeah, we're doing
What's happened?
or I'd say angle 1 and angle 4 are supplementary, and say, well, measurement of angle 1 plus measurement of angle 4 equal what? 180, and the reason would be definition of supplementary, right? And do you remember the reason for angle 1 and angle 4 being supplementary?
No.
What it was?
Lines?
The linear pair.
They're,
Linear pair theorem. Not pear like you eat.
Pairs.
A linear pair theorem.
Pairs.
it.
What was the linear pair theorem again? Oh. Okay.
Linear pair theorem basically says that if you've got 2 angles in a straight line, they are supplementary.
So what are those cases over there?
What cases?
Like the blue ball or
Math balls.
something. Sorry.
Okay.
Oh, alright.
I'm staring at my paper and I
Yeah,
I haven't
you
even
just like
thought
don't
of
even
it.
know what's going
You ever
on.
do that? You just like stare at
Yeah.
something and you're just
Yeah, I
staring
did
at it?
history.
Every day.
Just
That's
like-
like.
Every day. Every day.
Is that what you guys do in my class? It's like, I'm like, yeah, you guys get this?
You get it.
Yeah.
Alright.
Okay, give us the test.
It's like a bobble doll.
Not whiny.
Alright.
Bobblehead.
You mean a
Bobblehead. You know what I meant.
Bobblehead.
Okay, bobble dip. Bobble. Bobble.
Wow.
God,
Okay,
so-
alright.
That was hilarious.
Alright.
Oh, that was hilarious.
You got your number 1 fan over here.
That was not funny at all.
Okay.
I'll have fun with that.
Okay, John. Hi, Joel.
Oh,
These.
Naming polygons of n sides.
Why is the dolphin on the side?
On the wall, yeah. Are you trying to say something?
The dolphin fell down.
He's dead.
No, the dolphin is very much alive in our spirits.
Your spirit.
Yeah, sorry?
The dolphin will live there.
No, I'm just confused when you guys are done.
Okay.
Talking about these things.
All right, so I'm just going to throw some things out here on the board, and you're going to tell me what they are. All right? This is a what? Triangle. This is a
Square. Quadrilateral.
quadrilateral, right? This is a what?
Pentagon.
Pentagon. We're not at the quadrilaterals yet.
Oh my.
Pentagon.
Come on.
There yet.
What?
This is a
Hexagon.
hexagon. Very good. Now this one is always fun to draw.
Octagon.
It's a hexagon. Who's doing it in order, right?
Is there one for like 7 sides? 7 gone?
What's 7 sides is a
7 gone.
heptagon.
Heptagon.
Hepta.
Oh.
Heptagon. Heptagon. Okay. Next one. 8 sides is a
Octagon.
Not to be confused with an
9 is
octopus.
nonagon, right?
All right.
Nonagon.
Octagon, and then beyond there, I mean, it becomes a nonagon and a decagon. And it just goes forever. It actually does, like, I don't think it stops.
People make
Just
names
keep
for
naming
this.
them. And they just.
It's like this.
Well, no. It goes on to like 100-sided.
It's like their lives and just like writing names.
Yeah.
Really.
There's a whole board of shape polygon directors.
Oh,
The
yeah?
Polygon Naming Society, PNA.
Yeah.
Oh,
Right. Oh, PNA.
That'd be.
Yes.
Administration. That's what I meant to say.
Yeah.
That works. Okay. So we know how to name our polygons. Hey, how about
Yeah.
the test?
No, that's why we're learning it.
in the exam.
that? Generally speaking, what I don't know if it's going to specifically say
Name this shape.
name this shape,
Yeah,
because that
put
would
a,
probably
like
be a
a
little bit
triangle
too
and a happy
easy.
face in the middle.
But I might say, for instance, what's the measure of the interior angles of a regular octagon, right? Which moves us on to the next formula, which is for interior angles.
Okay,
Interior angles.
Sorry.
No, it's okay.
They've
It
been
just-
talking the whole time.
I always wonder what's going on over there in this little beehive.
Beehive? What?
No, I just saw.
These are like these.
Oh, I get it.
Okay.
I'm joking.
Whoa, family conflict.
I don't know.
Do we need intermediation?
I said I hate bees, and then she took it to like an
I'm taking it to
extreme.
court.
She didn't
I don't
took
know.
it like overboard.
Unjudged.
I know. I love bees.
There's a joke there somewhere. I'm trying to find it, but I don't know.
I promise you, all I said was I don't like bees. And then she did that.
Credits are wrong.
She went
Well,
ham.
listen, if it weren't for bees, you would never eat vegetables.
Exactly.
You wouldn't eat
That's not
any
true.
Or fruit.
But what?
Yay.
That's not true. You know,
If it weren't for God,
bats have a big
That's true.
contribution.
Bats and butterflies. You're right. But bees are very, very much a great thing on this universe planet because they
Yeah.
pollinate.
She just called me a
I don't understand
butterfly.
how a woman names her
She just called me a butterfly, so yes, she did.
I'm a butterfly. You didn't see that list?
Pointing
Wait,
this
it's
way.
like a human being.
Yeah,
She left and broke
And
up
all
her
the
bee.
animals that were on it.
I mean, maybe
That's
there's
just like
a
the
Me and
low.
Amanda made a list
No,
of everybody in our class.
I'm
and
pretty
put it
sure
in.
there's a
Bullseye.
biblical like intercession on that.
What was that, Rebecca? What was that, huh?
Anyway,
What am I, Rebecca?
no, there really is
Did you
actually.
read it?
The woman tried to hurt the
You
bee.
didn't read what he
And the
was?
man
That
tried
movie's
to.
blasphemous.
I was a monkey, now I'm just when the man tried to hurt the bee,
I'm a
tried to kill it.
butterfly.
And
What
then
am
the
I?
woman divorced the husband.
Can you just tell me what I
And then she
am,
went
man?
with me.
Jeez.
Can we just like learn this?
You're human.
I'm gonna be Joel for a second. Hi guys.
You
Dude. Interior angles.
Oh.
Alright. Theta equals what? Theta equals 180 times n minus 2 over n. 180 times n minus 2 over n, right? N is what? Number of sides. Okay, so everybody on your papers now figure out the interior angles
What number
in
is this?
a
That's 23.
pentagon.
We're talking.
Why'd we just-
Find the interior angles in a pentagon, please. I'm still No.
Gotta be.
By the way, this is an equation that you're going to have committed to your memory, working knowledge of and understanding.
Are you committed? Sorry, that was perfect, by the way. Alright, choir over here. So, you gonna tell me what I want?
Man, I thought you forgot.
Dude, I'm telling you, like,
You're more rap.
Raquel low-key, like, hates me, I promise you.
No, she doesn't.
Like, low-key, she, like,
Like low key, like low key.
Elemental P.
No, it says low key.
hey.
Okay.
High key.
Did everybody get
Yeah,
it?
exactly, she high-key hates me.
180 times 5 minus 2 over 5 equals 180 times 3 over 5 equals 540 over 5 equals 1. Did everyone get 108 degrees?
Yeah.
All right, you know how to do it.
I have a dummy number too. Yeah. It's on the other side, 'cause my mom says that it's really dumb. Of course it's gonna be dumb. I know, that's what I meant to say.
Okay, now class. I also have listed on there to find the number of sides of a polygon given its interior angle measurements. Okay?
How does that one happen?
This one's not just given.
The measurements of its interior angles. Okay.
And that'd be,
That person's face.
would that be the answer? Good.
Oh my. This is like instrumental.
Okay, so what about if I tell you that theta equals 144 and I say find n, find the number of sides of this polygon. Okay?
Oh, hold on a second.
See if you can do this on your own. Do you want to or you want me to go
I think
over
they
it?
use
I'll go
it
over it. I'll go over it. No?
Yeah.
Yeah, alright, so look. If theta is 144, the way that we had done this previously is I had you derive this formula algebraically.
Oh, yeah.
Right, you remember that?
I hate it.
But you don't have to do that, okay? This is what you should do.
Okay.
Just plug in 144 for theta, all right? Equals 180 times n minus 2 over n, okay? What should I do?
Well,
Distribute.
Multiply by n.
Multiply by n.
I multiply by n, and I get 144n equals, now I distribute.
So 180.
180n minus 180 times 2 is
360.
360. Now what do I do?
Move the 180 over to the other side.
Right, subtract 180n. And I get 144 minus 180 is 30, negative 36n equals 360. What do I do now? Equals negative 360. What do I do?
Divide by 36.
Divide by negative 36.
Whatever.
And I get what? N equals, it's negative 360 over negative 36, so it would
I
be,
know, dude, I know.
10. You guys got that? It's just algebra.
yep, got it.
You have, yes ma'am?
What's the equation?
This is the equation.
Yeah, there's another equation to that.
To solve this, there was another equation, but I don't want you to think about it necessarily because it's,
Don't think
I'd have to derive it right now anyway. And I think it's just easier for you to remember this equation and then do the algebra. Is that agreed?
Done or?
This class, this is finding the number of sides of a polygon given the interior angles. This is the interior angles. It's important because remember we talk about exterior angles as well. So this is interior angles. Good job. Goodbye. Goodbye.
Bye, sir.
We already got up to number 24, so
Because we have good, come on.
we only have
Bye, Dees.
25 through 41.
I thought it was today.
What did you say?
Yeah, it's not even today.
Say it again?
It's
Oh wait, everyone say goodbye to Joel.
Bye, Joel. Bye, Joel. Dees.